Okay. Strain compatibility equations. So we have derived equilibrium equations. On similar lines, we have the strain displacement relations. In last class, I had explained that. Let me restrict myself to two-dimensional Cartesian coordinates. So I have explained the same thing for three-dimensional in class 19. So that you can refer, that video you can refer class 19 video. Two-dimensional Cartesian coordinates if you take, you will be having only two displacements, u and v. So this is a two-dimensional element. Suppose if it is subjected to strain system like this. So instead of taking stress, I will take strain here. This is epsilon x. This is epsilon y. And we will be having gamma xy also like this. So this is gamma xy. Similar to stress, two-dimensional stress system, you have two-dimensional strain system like this. So here, this epsilon x, epsilon y, they are the normal strains or direct strains along x and y directions. X direction is like this, y direction is like this, whereas gamma xy is the shear strain or tangent strain. So always in SOM we have learned that shear stresses act in the complementary manner. That means if the shear stress or strain on this edge is like this, then on the other edge, opposite side, it will be like this. Similarly, if the shear stress or shear strain is like this on this edge, on the opposite edge it will be the opposite direction, so that these two will create one couple and these two will create another couple. They are equal, and for the equilibrium of the element they will be equal. One will be giving clockwise couple, another will be giving anti-clockwise couple. So this is a two-dimensional Cartesian system, strain system. We call it as strain system because instead of stress, I have written strain here. So in the case of stress, this will be sigma x, this will be sigma y, and this will be tau xy. These two will be tau xy. Now in the last class, I have derived strain displacement relations. So if I take u and v as a displacement in x and y directions, then you have a relationship between these displacements u and v and these strains epsilon x, epsilon y, gamma xy like this. So this I have explained in the last class. Epsilon x is given by dou u by dou x. Epsilon y is given by dou v by dou y. Gamma xy is given by dou u by dou y or dou v by dou x plus dou u by dou y. So this I have explained in the last class. So these are the strain components, out of which these two are normal strains. This is shear strain, whereas u, v, they are the displacements in x and y directions. Suppose if any body is subjected to some force at this point is p comma x comma y. So this can be anywhere here. So that is why x and y are taken as variables. Suppose if some forces are acting on this body, at this point P, we will be having both stress and strain. Sigma will be there as well as epsilon will be there at this point P. So if this point P is changed to P dash, if some displacement takes place like this, if the object deforms like this, if P shifted over here due to deformation, then here this horizontal displacement is u, vertical displacement displacement is V. This point is shifted here, like this. P is shifted to P dash due to the application of the force. This horizontal displacement, whatever it has displaced, is U, and this is, so that is the meaning of this. All the points will be displaced when it is subjected to external forces. Stresses and strains will develop at that point, and if this is the displacement, net displacement, P goes to P dash, horizontal displacement, that is in the x direction, displacement is U, and in the y direction displacement is V. Net displacement is this. This is the net displacement. So these displacements will have effect on the strain values using this V formula. So here you know that U and V, they are functions of x and y. Please note that U and V, they vary with respect to x and y. That means displacements will vary with respect to the point under consideration. Suppose if you take a point here, x and y will be different, and you have different values of U and V. Like that. From point to point, displacement will change. Suppose you take some another point, somewhere here, Q. This point may go here, it may go here. So then, at this point Q, this is U and this is V. It is changing. So that is why in elasticity we discuss with the stress at a point, strain at a point, like that. Now, by knowing U and V as functions of x and y, we can always find out the strains. So this type of problem I have done in the last class. Strain tensor. Given the displacement, how to find strain tensor. Now here, by using these relations, you can always obtain another one more equation called strain compatibility equation. So in a two-dimensional strain system, you will be having only one strain compatibility equation, whereas in three-dimensional strain system, you will be having 6 compatibility equations. So in class 19, I have explained all those 6 compatibility equations, and I have done a problem also. Here, to understand three-dimensional, you should understand two-dimensional first. So this is for two-dimensional. In the case of two-dimensional strain system, this is a two-dimensional strain system. In the case of two-dimensional strain system, you will be having only 3 strains, epsilon x, epsilon y, and gamma xy. You will be getting one compatibility equation. One compatibility equation you can derive. In the case of three-dimensional strain system, you will be having 6 components of strain. They are epsilon x, epsilon y, epsilon z, gamma xy, gamma yz, gamma zx. Totally 6 components will be there. You will be getting 6 compatibility equations. So those equations I have explained in the class 19. You can just go through them. Now today I will take up only in this class I will take up only two-dimensional strain system. So using these 3 equations, let me call these equations as 1, 2. So this is by definition. Using these 3 equations, we can arrive at the strain compatibility equation. Now let us derive the strain compatibility equation for a two-dimensional strain system. Now I will take one by one. First, I will take epsilon x is equal to dou u by dou x. What I do here is I will differentiate this both sides, differentiate with respect to y. If you differentiate with respect to y, you will be getting dou epsilon x by dou y. Of course, partial differentiation. This will be equal to, here it becomes dou square u by dou x dou y. Correct? So this is from definition. Strain displacement relation in x direction. am differentiating both sides with respect to y means dou epsilon x by dou y is equal to, here already derivative is there. Once again I have to differentiate means second derivative. Dou square u by dou x is already there. Once again you are differentiating, therefore dou y will come into picture. Partial differentiation. Because there are two variables, you have to take partial differentiation. Next, once again I will differentiate with respect to y. So 2 times I have to differentiate. Once again if you differentiate, this becomes dou square epsilon x by dou y square, and here this becomes dou cube u by, since I am differentiating with respect to y, dou x will be only once, but whereas here y will be 2 times. Correct? ಅರ್ಥ ಆಯ್ತಾ? So ಎರಡು ಸಲ ನಾನು I have differentiated with respect to y, I got this. So this I will call it as 4. So equation 1 is this, 2 is this, 3 is this, this is 4. Next, iದೇ ತರ same lines, what I do is I will take epsilon y, second equation, dou v by dou y. Correct? This I will differentiate with respect to x. Notice, what is the change we can see? Differentiate with respect to x 2 times. First I will differentiate with respect to x. If you differentiate with respect to x, what do you get here? LHS dou epsilon y by dou x1 is equal to ಇಲ್ಲೇನಾಗುತ್ತೆ dou square v by dou y dou x. Correct? Once again differentiate with respect to x. Once again differentiate with respect to x. This becomes dou square epsilon y by dou x square, and this becomes dou cube v by dou y dou x square. Correct? X also y also. This you can take it as equation 5. So what I have done, I have differentiated epsilon x twice with respect to y. I got this. I have differentiated epsilon y twice with respect to x. I got this. Next, I will take the third one. The third equation is gamma xy is equal to. So how to write gamma xy? So I will write in the denominator x, dou x and dou y. So for x you have to take v, for y you have to take opposite. This is how we can write the shear strain component. Third equation I have used now. Illen ಮಾಡ್ತೀನಿ, once I will differentiate with respect to x, second time I will differentiate with respect to y ಮಾಡ್ತೀನಿ. ನೋಡಿ ಇಲ್ಲಿ with respect to y ಎರಡು ಸಲ, ಇಲ್ಲಿ with respect to x ಎರಡು ಸಲ, ಇಲ್ಲಿ ಒಂದು ಸಲ x ಒಂದು ಸಲ y. So differentiate with respect to x. ಏನು ಬರ್ತದೆ dou gamma xy by dou x is equal to, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ dou square v by dou x square plus dou square u by dou y dou x. Correct? With respect to x ಮಾಡಿದಾಗ here already x is there, so one more x will come. Here y is there, so x will be taken. Next step, I will differentiate with respect to y now. This one I will differentiate with respect to y. So what do you get? Dou square gamma xy by dou x dou y. This should be equal to this. If I differentiate with respect to y, dou cube v by dou x square dou y plus this. If I differentiate with respect to y, dou cube u by dou y square dou x. y ಎರಡು ಸಲ ಆಗುತ್ತೆ. Now you can call this as equation 6. So from equations 1, 2, 3, we got equations 4, 5, 6. Now we have to just see these three equations. 4, 5, 6. If you observe, what you can say? In equation 4, see the LHS. In equation 5, see the LHS. You just add them. Dou cube u by dou x dou y square. this term, correct? Dou cube V by dou y dou x square means this term. So whether it is dou y dou x square or dou x square dou y, they are same. That's like that, they are same irrespective of the order. So that means these two LHS, if you add, RHS if you add, you are going to get the RHS of the third equation. That means if you add the LHS of these two, it should be equal to this. Correct? So from what we can observe is we have RHS of 4 plus RHS of 5 is equal to RHS of 6. Okay? Correct? Even these two if you add up, you are getting this. Therefore, what you can say, LHS of 4 plus LHS of 5 should be equal to LHS of, correct? Equal ಆಗಬೇಕು. RHS equal ಆಗಬೇಕು. ಅಂದ್ರೆ ಏನಾಯ್ತು ನಿಮಗೆ? What you can write? What is LHS of 4? Dou square epsilon x by dou y square plus dou square epsilon y by dou x square. This should be equal to dou square gamma xy by dou x. So this equation is called as the compatibility equation in two dimensions. Strain compatibility equation. Strain exactly because this equation contains epsilon x, epsilon y and gamma x. Strain components. Similarly, you have stress compatibility equation also. We can derive that also, but it is not there for here. We will derive later. So, this is strain compatibility equation. Simple derivation. You can go. Derivation can go. 4 marks to 6 marks you can go. So, derive the two-dimensional strain compatibility equation. Then what we know is more work first. These three you have to write that. Then you have to differentiate equation 1 with respect to y. Differentiate equation 2 with respect to x 2 times. Differentiate equation 3 with respect to x and then with respect to y. Then compare. If you compare, sum of the RHS of 4 and 5 will be equal to RHS of 6. Therefore, LHS of 4 and LHS of 5 if you add, you are going to get LHS of 6. Therefore, this is the. Either may problem kodu. So let me take up a problem. Check ಮಾಡಿ ಅಂತ ಕೊಡ್ತಾನೆ. Whether the compatible strains, given strains are compatible or not. So you can write down the problem. So two-dimensional strain problem. The components of strain at a point. Problem is like this. The components of strain at a point. Components of strain at a point in a body are given by components of strain on the usual epsilon x, epsilon y, gamma x. There is a normal strain or the shear strain. Epsilon x is C1z into x square plus y square. C1z into x square plus y square. ಇಲ್ಲಿ ಮೂರೇ ಬಿಟ್ಟಿದ್ದಾರೆ. Epsilon y is x square z. And gamma xy shear strain is 2c2 xy. 2c2 xy. Here c1 and c2 are constants. They are constants. The question is like this: check whether the strain field is compatible or not. Check whether the strain field means these three strains, is compatible or not. This is the problem. So it is compatible or unwanted. The equilibrium equation is different, compatibility equation is different. In structural analysis also, independent structures are analyzed using compatibility equations. Equilibrium equations we can use to analyze statically determinate structures, whereas statically indeterminate structures, they are analyzed using equilibrium equations along with compatibility equations. Slope deflection method, moment distribution method, they are all using this compatibility equation. See here, since he has given only three strain components, the compatibility equation to be satisfied is compatibility equation to be satisfied is, so only one equation has to be satisfied. The equation is, just now we have derived it, dou square epsilon x by dou y square plus dou square epsilon y by dou x square should be equal to dou square gamma xy by dou x. Correct? This equation, if it is satisfied, then we say that the strain field is compatible. If this equation is not satisfied, then it is not compatible. Now he has given the strain components, we need these derivatives now. So we call this as equation 1. So he has given epsilon x as c1z into x square plus y square plus 1. So I need dou square epsilon x by dou y square means I have to differentiate this with respect to y 2 times. If you differentiate first, dou epsilon x by dou y is equal to, when you are differentiating with respect to y, we have to keep x and z as constants. Okay, the differentiation c1z is I can write it as c1z x square plus c1z y square. So when you are differentiating with respect to y, this becomes a constant because there is no y term here. So other derivative 0 are going. Correct? The derivative of this first term will be 0 plus derivative of second term will be c1z into 2y. That means it is 2c1z y. X and z constant, c1 constant. Since this term does not contain y, so derivative of this will be 0. It is taken as a constant. Derivative of constant is 0. Next, once again differentiate with respect to y 2 times. Then you will get second derivative, dou square epsilon x by dou y square. This will be equal to, so derivative of 0 is 0. Here, derivative of this with respect to y is, this is a constant, 2c1z into 1. Derivative of y is 1. So this is what we get. So the first term we got now. So you can call this as 1. This is Roman 1 now. This is number 1. Next, second what we have to do? We have to take the second expression. Epsilon y is equal to x square z. We have given x square z. So this we have to differentiate with respect to x 2 times. How is it? So ಇದನ್ನ with respect to y ಮಾಡಬೇಕು 2 times epsilon x ನ epsilon y ನ with respect to x 2 times differentiate ಮಾಡಬೇಕು. So differentiate with respect to x. So we get dou epsilon y by dou x. Here, since you are differentiating with respect to x itself, here z is constant. Derivative of x square is 2x. So 2xz. We we get like this. Once again differentiate with respect to x. So you get dou square epsilon y by dou x square. If you differentiate this with respect to x, ಏನು ಬರುತ್ತೆ 2z ಬರುತ್ತೆ ಅಲ್ವಾ 2z into 1 derivative of x is 1, so 2z. So this is the second term, number 2. ಎರಡು ಬಂದಿದೆ, first and second over. Now third one. To get the third one, I have to use this. Then this gamma xy. Gamma xy is equal to, he has given 2c2 xyz. Here, to get this term, RHS term, once I have to differentiate with respect to x, next I have to differentiate with respect to y. So again, first I will differentiate with respect to x. So dou gamma xy by dou x will be equal to, x is variable here, all others are constants, so it becomes 2c2 yz into 1. Derivative of x is 1. So you will get 2c2 yz. Next, once again differentiate with respect to y now, second time. So you will be getting dou square gamma xy by dou x dou y, which is the required RHS. If you differentiate with respect to y, this one, so 2c2z into 1. So that is 2c2z. So I take this as 3. Now we got all the 3. First term is this, second term is this, third term is this. Now you will check whether you are going to get LHS is equal to RHS. Now LHS of 1 is equal to dou square epsilon x by dou y square plus dou square epsilon y by dou x square. Now just substitute that, 2c1z plus 2z. That is, you can get 2z into c1 plus 1. This is what you get. Correct? LHS of 1. What is RHS of 1? It is dou square gamma xy by dou x dou y, which we got as 2c2z. 2c2z. Now just compare these two. Compare these two. Whether they are same? Same idea, equal idea. This is equal to this one idea. ಬಂದಿದೆಯಾ? ಇಲ್ಲಿ LHS ಬಂದಿದೆ, RHS ಇಷ್ಟು ಬಂದಿದೆ. ಎರಡು ಈಕ್ವಲ್ ಇದೆಯಾ? ಇಲ್ಲ ಅಲ್ಲ, ದೇ ಆರ್ ನಾಟ್ ಈಕ್ವಲ್. ಅಂದರೆ ಕಂಪ್ಯಾಟಿಬಲ್ ಇಲ್ಲ ಅಂತ, ದೇ ಆರ್ ನಾಟ್ ಕಂಪ್ಯಾಟಿಬಲ್ ಅಂತ. ಸೊ LHS is not equal to RHS because LHS is 2z into c1 plus 1, RHS is 2c2z. So they are different. Therefore, the given strain field is not compatible. A equation satisfy agಲಿಲ್ಲ ಅಂದ್ರೆ compatible ಅಲ್ಲ. Got it? It is not compatible. ಎರಡು ಈಕ್ವಲ್ ಬಂದ್ಬಿಟ್ರೆ ಇಲ್ಲೂ 2z ಇಲ್ಲೂ 2z ಆ ಥರ ಬಂದರೆ ಅದು ಕಂಪ್ಯಾಟಿಬಲ್. ದಟ್ ಇಸ್ ಮೀನಿಂಗ್ ಆಫ್. ಸೊ ಅವನೇನು ಕೇಳಿದ್ದಾನೆ, ಚೆಕ್ ವೆದರ್ ದಿ ಸ್ಟ್ರೈನ್ ಫೀಲ್ಡ್ ಇಸ್ ಕಂಪ್ಯಾಟಿಬಲ್ ಆರ್ ನಾಟ್. ಸೊ ಇಟ್ ಇಸ್ ನಾಟ್ ಕಂಪ್ಯಾಟಿಬಲ್ ಬಿಕಾಸ್ LHS is not equal to RHS. ಇದರಲ್ಲಿ ನಾವು ಏನು ಮಾಡ್ಬೋದು ಅಂದರೆ, ಸಪೋಸ್ ಇಫ್ ಇಟ್ ಈಸ್ ಟು ಬಿ ಕಂಪ್ಯಾಟಿಬಲ್, ವಾಟ್ ಈಸ್ ದಿ ಕಂಡೀಷನ್ ಶುಡ್ ಬಿ ಸ್ಯಾಟಿಸ್ಫೈಡ್ ಅಂತ ಕೇಳ್ತಾನೆ. ಇದರಲ್ಲಿ ಇಲ್ಲೊಂದು ಲೈನ್ ಸೇರಿಸ್ಕೊಳ್ಳಿ. ನೆಕ್ಸ್ಟ್, ಇಫ್ ದಿ ಸ್ಟ್ರೈನ್ ಫೀಲ್ಡ್, ಗಿವನ್ ಸ್ಟ್ರೈನ್ ಫೀಲ್ಡ್, if the given strain field is to be compatible, if the given strain field is to be compatible ಆಗಬೇಕಾದ್ರೆ ಏನಾಗಬೇಕು ಅಂದರೆ LHS should be equal to ಆರ್ ಎಚ್ ಎಸ್ ಆಗಿದೆ, ಕರೆಕ್ಟಾ? ಎಲ್ ಎಚ್ ಎಸ್ ಏನು ಬಂದಿದೆ? 2z ಇಂಟು C1 ಪ್ಲಸ್ 1. ಆರ್ ಎಚ್ ಎಸ್ ಏನು ಬಂದಿದೆ? 2C2 z ಬಂದಿದೆ. ಇವೆರಡು ಈಕ್ವಲ್ ಆಗುತ್ತೆ. ಈಕ್ವಲ್ ಆದರೆ ಅನ್ಕಂಪ್ಯಾಟಬಲ್ ಇರುತ್ತೆ. ಈಗ ಈಕ್ವಲ್ ಮಾಡಿಕೊಂಡ್ರೆ ಇದೇನಾಗುತ್ತೆ? ಒಂದು ರಿಲೇಶನ್ಶಿಪ್ ಬರುತ್ತೆ C1 C2 ಗೆ. ಇದು ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತಲ್ವಾ? 2z 2z ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಏನು ಕೊಡುತ್ತವಾಗ? C1 ಪ್ಲಸ್ 1 ಇಸ್ ಈಕ್ವಲ್ ಟು C2 ಅಥವಾ C1 ಮೈನಸ್ C2 ಅದು C2 ಮೈನಸ್ C1 ಅಂದರೆ ಈ ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆದರೆ ಆಗ ಕಂಪ್ಯಾಟಿಬಲ್ ಆಗುತ್ತೆ ಅಂತ. ಅರ್ಥ ಆಯ್ತಾ? ಆ ಥರ ಕೇಳ್ಬೋದು. ಫಾರ್ ವಾಟ್ ಕಂಡೀಷನ್ ದಿ ಗಿವನ್ ಸ್ಟ್ರೈನ್ ಫೀಲ್ಡ್ ಇಸ್ ಕಂಪ್ಯಾಟಿಬಲ್. ನೀವೇನು ಮಾಡಬೇಕು? ಇಷ್ಟು ಮಾಡಬೇಕು. ಕಂಪ್ಯಾಟಿಬಲ್ ಆಗಲ್ಲ ಅಂತ ತೋರಿಸ್ಬೇಕು. ಕಂಪ್ಯಾಟಿಬಲ್ ಆಗಬೇಕಾದ್ರೆ ಎಲ್ ಎಚ್ ಎಸ್ ಶುಡ್ ಬಿ ಈಕ್ವಲ್ ಟು ಆರ್ ಎಚ್ ಎಸ್. ಅದನ್ನು ಈಕ್ವೇಟ್ ಮಾಡಿ ಯು ಕ್ಯಾನ್ಸಲ್ ದಿ ಕಾಮನ್ ಟರ್ಮ್ಸ್. Whatever is remaining, so that condition you have to take. That means finally what you can write here is, so this C2 minus C1 is equal to 1 is the condition for compatibility. A satisfy ಆದರೆ compatibility ಇಲ್ಲ ಅಂದ್ರೆ ಇಲ್ಲ. ಈ ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಅಂದರೆ C2 ವ್ಯಾಲ್ಯೂ 3 ಇದ್ದರೆ C1 ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಾಗಬೇಕು? 2 ಆಗಬೇಕು. 3 ಮೈನಸ್ 2 ಇಸ್ ಈಕ್ವಲ್ ಟು 1 ಅಲ್ವಾ? C2 ವ್ಯಾಲ್ಯೂ 10 ಇದ್ದರೆ C1 ವ್ಯಾಲ್ಯೂ 9 ಇರಬೇಕು. ಆಗ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗುತ್ತೆ. ದಟ್ ಈಸ್ ಮೀನಿಂಗ್. ಸೊ ದಿಸ್ ಈಸ್ ಹೌ ಯು ಕ್ಯಾನ್ ಸಾಲ್ವ್ ಎ ಪ್ರಾಬ್ಲಮ್ ಆನ್ 2-dimensional strain compatibility equation. ಸೊ ಕ್ಲಾಸ್ 19ನಲ್ಲಿ 3-dimensional ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ದೀನಿ, ಈಕ್ವೇಷನ್ಸ್ ಎಲ್ಲ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ದೀನಿ. ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿದ್ದೀನಿ ಅನಿಸುತ್ತೆ ಮೋಸ್ಟ್ಲಿ ಅಂದರೆ. ಅದನ್ನು ನೀವು ಗೋಲ್ಸಿಲ್ಲ, ಅದು 3-dimensional. ಬಟ್ ಸಾಮಾನ್ಯ ಡಿರೈವ್ ಮಾಡಿ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಈ ಥರ ಕೇಳ್ಬೋದು. 8 ಮಾರ್ಕ್ಸ್ 10 ಮಾರ್ಕ್ಸ್ಗೆ ಡೆರಿವೇಷನ್ ಕೊಟ್ಟು ಈ ಥರ ಪ್ರಾಬ್ಲಮ್ ಕೊಟ್ಟು 10 ಮಾರ್ಕ್ಸ್ ಇರ್ತಾರೆ. ಸೊ ಆ ಕಂಡೀಷನ್ ಓನ್ಲಿ ಒನ್ ಕಂಡೀಷನ್. ಫಾರ್ ಎಪ್ಸಿಲಾನ್ x you have to differentiate 2 times. For epsilon y you have to differentiate 2 times with respect to x ಮಾಡಬೇಕು. ಎಪ್ಸಿಲಾನ್ x ನ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು y ಮಾಡಬೇಕು. ಗಾಮಾ ಎಕ್ಸ್ ವೈನ ಒಂದು ಸಲ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು x ಮಾಡಬೇಕು. ಅನದರ್ ಟೈಮ್ ಯು ಹ್ಯಾವ್ ಟು ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು y. ಎಲ್ ಎಚ್ ಎಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಆರ್ ಎಚ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ದೆನ್ ಪ್ರಾಬ್ಲಮ್ ಇಸ್ ಲೈಕ್ ದಿಸ್. ಯೂಸ್ ದಟ್ ಕಂಡೀಷನ್ ಆ್ಯಂಡ್ ಗೆಟ್ ದಿ ಆನ್ಸರ್.